Hello guys, my name is Akansha, and today we will discuss the flow of the payment status system. Last demo we see if we put the all logic, it is nothing but the payment logic inside our main merchant system is nothing but the here. Everything gets the mix up. Here we see like the business logics are like order or user name or payment code. All these things are getting messed up here. So uh, think are like if you want to make the same change in the future, so do I have to deploy this entire system as every time? So the key payment system is the separate is nothing but the clean and the focus. So why? Because what if the PSPs are fail in the future? The payment service providers are like the Razorpay or payment. So imagine if we are using the only one PSP here inside our payment integration, so there may be in futures like the server will be down and the payment will be get the fail. So that's why we separate this merchant system, this payment integration, and this PSP. We discussed these things in a last session. So today and also we discuss this uh, payment validations is nothing but the validation framework we build as a coding part. And today we will see what is the end flow of our payment status systems and why it's needed. And last we discuss about the all the validations related logic, what's this framework is going to do. We discuss. If we miss this topic, you can see the last video. Okay, so let's get started. System we build is including like there is going to be the merchant system is here. It's letting and PSPs is there. We will having the three microservices validation related framework, then process is related, and trustly provider is there. So merchant API will having the multiple components here, like this is our front end part and this is nothing but our back end part of our merchant system. So how the end to end flow will be happen? So the end user is nothing but this one. So this guys is a click on the trustly options. Yeah, there may be this a card page or order page, something like that. So do the request is this is request is going to this backend here, backend system of our merchant system. So what is the processing with? So what they the request is the top of the backend system and it will be identified. So we need to go with our processing system. They will be calling this validation service, nothing but this will be calling to this validation service based on the call or APIs we have given. So our systems have the endpoints here. This is our system which is giving the endpoints is nothing but we discuss is nothing but the APIs or REST API, which is have the logic which is the other system can call our API or uses or reuse the our system logic from the another system. So this is nothing but the endpoints here, and the call that endpoints um, endpoints from this business logic which is written by the merchant system here. And we'll first doing the security check here inside the validation framework. Are we used here the HMAC uh, HA. So HMAC I think 256 we use here. uh, so it will secure our application. We implement this, and the next will happen. There we have the validation framework code which will run the validation logic or optional rule. So the request is going to taken its first and it's verify, and this then next is validation framework will run the all rules which are we written, and once the everything going is good, the validation framework will call the first API of our payment processing service here. So after that some database, okay here. So as soon as the request come, it will save in the database whatever the request related data comes, which is get from the at the rate request body. It will collect and store inside the database, and uh, it will goes and create status here. Once the request come and store, it will select it and it will store inside the database this request is created. So we can say the first is nothing but this create is done here. Okay, this create is done, and then the response back to this validation service is nothing from here to here. It goes to the validation service, and it's done. The next is going to pass this second request here. So with the request is have the data which is needed for the making the further nothing but the third party call. So when the this second request nothing but this one request is identify the request response via Trustly, and then it's called to the Trustly provider here. And the next the Trustly provider will actually calling to the external Trustly system. This is the Trustly integration provider, and this is our actual Trustly logic. Okay, so when the second request come before the calling this request is Trustly provider, we have to update this create to this initiate. Okay, so first the data came from the validation service, and when it is stored inside the database, so that time this creates status is stored inside the database. But when the data is already stored and it's get back to the validation, and validation it's given some extra data for the third party calling, it will again goes to the our processing service, and before calling this Trustly integration system, it will be goes inside the database and the update this create to the initialize. Okay, so now it is initialize here. So before calling to any from the there, it goes to initialize. So next make its initialize, and we call to the their Trustly providers, and the Trustly provider system is a response then is and came back here as soon as get valid URL or some order ID here, it will goes into the pending here. What is this? Nothing but here. It is goes inside the pending. And it means we are waiting for the end customer here. Okay, we are waiting for the end customer to make the payment, and we given the response back to this one guys, and then the validation return the front end system, and back end there return the actual front end from the here. It will return to the actual uh, front end according to redirect page which are given by the trustly provider. And this kind of the redirection flow will be happen from the trustly, and this trustly is provided the hosted page URL which is not given to the end user directly. It is nothing but the merchant system is going to the here is nothing but the hosted payment page. So customer will complete the activities here with the trustly, whatever the success or failure activities are there, and it will notify. There's nothing but the whatever the request given by the trustly, in which have some data is like the username or password is there. So it this username or password it's not written back to this trustly system. So here we can say our end user data is clearly safe, because whatever the data we are passing in the hostess page which is given by the trustly, those data will be not goes into this backend system. It will directly connect into our end bank. Okay, so we are giving this validations like our logging system is there, which data you pass, which password is passed is all directly collect inside the bank page, is also called as the issuer bank. Okay, so this things is here, and the whatever the logic perform in the hosted page is nothing but the like a payment is successfully, and the failure, those things are notified to the uh, trustly from the bank page. They not have the intercommunication between the data, but it's have the clear communication with the notification. So whatever is going to happen inside the hosted page, end-to-end notification bank will provide to this trustly. Okay, because the integration is happen with the bank and trustly, it is not in the end user. So before we see, the multiple PSPs are included in our system. So we in not our system in a PSP. So whatever the integration having between the each bank, those all integrations are separately. Okay, so we no need about that integration. We just need to connect with the trustly. Trustly will going to handle those all integration about the all banks. And this PSP is having the gateway which is having the multiple bank options here. Okay, so next is so there is this notification system here, so which notify the multiple status here. So whenever we get this notification, they will inform us the whatever its success or failure like that. So based on this response, we have to update this system is like uh, there may be here the success. Oh, there may be this success or the failure. Okay, the status can upgrade according once the final status is come from this notification here. Hmm? And the further work is informed to the merchant system uh, here. From the here it will inform to this active MQ, and active MQ it inform to this or merchant system. Okay, so this flow will be going like this and going to this. So some this active MQ, or there have something like the Kafka, or these are the message broker, and then send the request are like the synchronize or async manner. So based on our project requirement, we can send this request. So this is the full status flow. So the payment system is a help to this payment system is help to tracking the progress about the given the payment, and the different point of system this value will be update this one. So as soon as we get the first request from the merchant, it will create. When it gets the second request, before calling to the trustly provider, we update it ads and initiate it, and then we get the URL back from the here, and mark it as when the get the URL from the actual merchant, it will goes into the pending, and return this URL to the customer, make it the payment notification, and commit we discusses the whatever the success or failure. Yes. So once the final status happen, we need to communicate with this trustly via this active MQ or Kafka messenger. Okay, so today we build and the payment status tracking system. So the 70% coding is done. You can see here our 70% coding is done actually here. Our packages are like the which is start from the Hulk, Hulk tech payments, and the next is nothing but our whatever the configuration logic we have, we kept inside the separate package. Okay, there have our application config here, in which we use the model mapper. So model mapper we use to convert our one data to another. It gets simply think here, and then we have our actual controller here. There we use some annotations are like REST controller or REST mapping and SLF4J required arg constructor. We discussed already this annotation in a previous video. So this REST controller is nothing but when we develop any applications is like the business to business communication. So that time we use this REST controller. And then we have the request mapping when the end browser is sending the request to our controller. So on which resources is sending this payment resources is identify and get into these classes. And then we use this SLF4J for the log tracking. Is nothing but the whatever the flow of our application at runtime, we can track it easily from this SLF4J. And then we have the required arg constructor. So the required arg constructor we mainly use when we if we want any constructor and we don't want to define in our class, so no need to define in the class, just annotate this class with the arg constructor, whatever the required constructor which needed in our class, which is taken care by the Spring Boot. Okay, so here our uh, method is nothing but the create payment here, and which is also pass the response as the create transaction response. Okay, so we get the data by the annotations are nothing but the request body, and getting the data like the create transaction request, we get this data, and for the tracking we return inside the logger, and to save this data we pass this data to this create payment method, which is nothing but our payments service class. We get into the class. Okay, from this. So one thing I noted here, so firstly I not given this final inside the class, and I get in the more error, at least the 30 to 1 hour I find the error, but I am not getting. But after that I recognize the error and find the answer is like, whenever we give the request our constructor here, we need to this value is like the final, and final it needs to initialize. So whenever we give the request our constructor now, so uh, recognize these things, we need to create this field is the final. Okay, so the next we create the successfully this payment and pass the response to our end user is nothing but our merchant. So this is nothing of our payment controller. And then we have the implementation classes and the interface here. This is the transaction DTO. So first we see here, this is nothing but our transaction request. So whenever we process further, no need to pass this request every time. Okay, we kept those requests inside this transaction DTO. This is our implementation class. Whatever the request, we get this and store inside the database. Okay, and this is passed to the result. It is a failed or success. If it is a fail, uh, which or how much line it's getting affected, it is giving the result here. And then we have some DTO class which is contain some fields are like the ID, username, payment method ID. This is the master data. This is the main data in our application which contains the reference from the one table to another table. And this is the error code and error message. Then we have the entity class. As we know, the entity class is nothing but whenever we map our data to the table, we need to use the entity class. So whatever we field have inside this entity class, which is directly mapped into this database, we will see we have our database, own database. So whatever the field we have here, like ID is here, username is here. We can see there is ID, username. Then we have the payment method, provider ID, payment type, and transaction status code. So these things are kept inside our database when we create our class as a entity. So whatever the field is have here, which is assigned, is nothing but our column. Okay, these things. And then we have the Pojo package. Pojo package is nothing but the plain Java object. This is our create transaction request here. So when the request came from the merchants are like the user ID, payment method ID, provider ID, then payment type ID, then amount, currency, merchant, transaction reference. So this request came from the merchant system. We see from where it came. So this is nothing but our simple merchant system here. We can say it is. So this is nothing but our user ID. So we kept those data inside the body JSON. So whenever we use this postman, so came to this body and then select this JSON, then came back here and pass this user ID, payment method, and this all data. We can see whatever the request came here, our backend responsibility to catch this data from the merchant, nothing but our front end system. So this is our request, and then we have the response. So this is request, this is response. So what data we have to pass to the merchant, we also create those class here. This is nothing but the create transaction response. So what data we pass to the merchant here? So transaction status id we pass. So when this data came it here, we collect this data and send to further to this after validations is go to the processing, and then it is trustly provider, and then actual trustly system which gives the order id and url. After getting all successful payments are successful, it's get back to the response, and from the response is passed this transaction id, and transaction reference is nothing but this request, sorry, this response we get from the backend here, which are nothing but this transaction id here and the transaction reference. Okay, then we have some service implementation classes here. This is nothing but our payment service. We just see this logic here. This have our transaction dto model mapper, and then create status handler here. Those fields are required here, kept it as the final, so anyone cannot the override this field here. And for the logging purpose, we kept this some logic inside the logger, and then we create this transaction reference. So this uuid is nothing but the universal id which is unique from the any value. So whenever we have the requirement, I like the get the unique value, so don't use this map and some unique characters are like, just use this uuid and random uuid method. It will give some structures, values are unique, and we kept it as the string here. And then we have this transaction id. Here we use this like the hard coded this value, but in the future coding we will change it and make it as the enum, or just like the uuid, we will kept it as the separate here. Okay, then we create here this transaction status handler object and pass it to this dto and set it some values are like this transaction status id and reference here. And here we create this transaction reports we get in the from the front end, it's get to the from the back end. We can see here now this is transaction status is 1, and this is the reference. It's came from this logic, guys. Okay, so we map this transaction detail here and get to the response, and then we created this create status handler. Today we discuss about this create, pending, and the success, failed, initialize. This data is come from this create status handler uh, class, which is implement the transaction status handler, and this some interface we have inside our applications, like the payment service, which is have one methods are create payment, which is take the parameter as the create transaction request and get the uh, re response is also the create transaction response here. Then we have this transaction status handler, which is kept the logic of the create, initialized, and pending success, fail or cancelled here. So this is how our main logic of our payment processing service is nothing but the one of the microservice of payment integration system here. So here the main entry point of our applications are nothing but our payment controller. And the guys is one thing is This payment controller it should lightweight, because inside our microservices principle we say see like the smart endpoints and dump pipe. So these things we have the kept inside the mind when we are doing the coding. Okay. So this is our controller which is so lightweighted. It's have only the this is nothing but our method is sorry, this is the one line statements which is inform us to what's going on in our application. This is not the business logic. This is for the our understanding purpose. So inside our one method we kept only the one logic is nothing but the payment service dot create method, and we pass this create transaction request here, which is also response as the create transaction response here. So loosely coupling is happen here because there may be a chance of the create transaction request is have the multiple implementation classes. So whenever it's going to return back, we kept inside the interface are nothing but our create transaction response. So whatever the implementation class is having in our application, we easily kept those data inside this, and just we response this is as the response body here and request transaction body. So this is nothing but our um, payment processing services. So there have some extra logic is here, we will discuss in next video. So so today we will be build on the payment status tracking system here. Okay. So 70% code is done here. So remaining we will do it this in this month, we will try to complete. Okay. And so this system is ensure we track uh, every payment accurately without relying or browsing or redirect. So using this trustly like credit, debit or cancel or notify, we maintain the clean status flow here. So credit or initialize the pending, success and the failed. So all handle in this central data in this processing service. So using the Spring JDBC and MySQL, this makes our system is a secure, reliable, and easy to maintain. So we always know what's happening in the payment system by using this status code or status information. So this is our payments status system, guys. So once we complete the all services, we will try to connect with the Angular. So and once it's done, so I will show you how our payment application system will look. Okay. And so guys, keep learning and keep practicing. Meet you soon in the next video. Thank you.